Welcome to Scholars Edge tutorial. In this video, we would be looking at indices, laws of indices, and how we can apply these laws in solving questions. So first of all, the first law of indices we'll be looking at is the multiplication law. So the first law we have is the multiplication law. The multiplication law states that if we have two bases that are multiplying, same bases that are multiplying, we add their powers. How do we mean? Now this is what I mean. When you have a squared times a cubed, you can see a and a is the same, so it's the same base. A squared times a cubed. What do? We take one, we'll pick one, so we'll pick 1a and add the powers. So we'll be having a raised to the power of 2 plus 3 because we are adding the powers. We pick one base and we add the powers 2 plus 3, and we'll be having a raised to the power of 5. That is what the multiplication law states. So this is a simple example or simple illustration for the multiplication law. Okay, what if maybe you had a squared times b cubed? In that case, we will not do anything. We cannot pick one base because they are not the same base. This is a, this is b. So this law only applies when we have same bases. Okay, let me show you guys another illustration. So when we have something like this, a squared times b raised to the power of 4 times a raised to the power of 5 times b raised to the times b squared times c raised to the power of 3, what do we do? Now this same multiplication law applies here. We just pick out the one with the same base. You can see a here, we have a here, we have a here, we pick out one, and what do? We add the powers. We have b here, we have b here, we pick out one and we add the powers. And we just have one c here, so we pick out this one c. So we'll be having a to the power of 2 plus 5. You can see 2 here, we have 5 here, so 2 plus 5 times b to the power of 4 plus 2 times c raised to the power of 3. So we have a raised to the power of 7 times b raised to the power of 6 times c raised to the power of 3. And that is our final answer. So this is all about the multiplication law. The next law we'll be looking at is the division law. So for the division law, if you have two bases that are the same, that are dividing, what do? We pick out one base and we subtract their powers. That's almost the same thing we are doing here, but this time we are subtracting. So assuming we have a cubed divided by a squared, what do? Since their bases are the same, a and a, we pick out one a and we subtract their powers. So we do 3 minus 2. And if we do a 3 minus, so we have 3 minus is 1, so we have a raised to the power of 1, and a raised to the power of 1 is what? A. So we have a. So this is all about the division law. Next law we are looking at is the power law. So for the power law, when you have something like this, a raised to the power of m, no bracket, to the power of n, sometimes you see questions like this. A number raised to the power of a certain number, and it will be enclosed in the brackets raised to the power of another number. What you just have to do is do m times n. M times n. So the answer for this is a raised to the power of m times n. M times n is what? Mn. So we have a raised to the power of mn. So you just multiply the two powers, the one inside the bracket and the one outside the bracket, and a raised to the power of those two powers. So we will be having a raised to the power of mn. Now what if you have something different, like you have two numbers inside these brackets, like something like this, a b to the power of m including the brackets to the power of n? What you just have to do, you can see this is only this b that is to the power of m, this a is on its own, only this b that is to the power of n. What you have to do is this n will affect the two numbers here, so a will be raised to the power of n, and since this one is already raised to the power of m, we just multiply the powers, m times n, so b will be raised to the power of mn. So this b will apply this principle, and this a will just take its own power. So we'll be having a to the power of n, b to the power of mn. This is for the power law. The next law we'll be looking at is the zero index law. So we have the zero index law. For the zero index law, it states that anything raised to the power of 0 is 1. Anything to the power of 0 is 1. So if we have a to the power of 0 is equal to 1, this law only stands if a is not equal to 0. If a is not equal to 0, then this law stands. But if a is equal to 0, this law cannot stand. So as far as a is equal to any other number apart from 0, then this law stands. So anything raised to the power of 0 is equal to 1. So if we have 8 to the power of 0 is equal to 1, 9 to the power of 0 is equal to 1, 10 to the power of 0 is equal to 1. So our next law is the negative index law, and this one states that if you have something like a to the power of negative n, this means 1 over a to the power of n. Because of why we are taking 1 over, because of this negative sign here. If this was ordinarily just a to the power of n, it would have been different. It would have just been a to the power of n. But the fact that there is a negative sign can still be a negative index law. The fact that there is a negative sign, it will introduce the 1 over, then you can take a to the power of n. So a to the power of negative n can be written as, or means 1 over a raised to the power of n. So let's look at an example. Assuming we have 2 to the power of negative 3. 2 to the power of negative 3. This can be written as 1 all over 2 to the power of 3. Since we've introduced this 1 over, we'll remove the minus sign or negative sign. So we're having 1 over 2 to the power of 3. And 2 to the power of 3 is what? 8. So this will give us 1 all over 8. So our final answer is 1 over 8. Now this is for negative index law. The next law we'll be looking at is the fractional index law. So for the fractional index law, it states that whenever we have something like a to the power of a fraction, like a to the power of m over n, this means that we will be taking the nth root of a to the power of m. How? Assuming n is 2 and m here is 1, so we maybe a to the power 1 over 2. So we'll be taking the square root, because we'll be taking the square root of a to the power of 1. Now let me express this properly. So this is the nth root of a to the power of m. Whenever we have a number raised to a fraction, we take the denominator as the root. If this denominator is 3, we take it as cube root. If it's 4, we take it as fourth root. So the denominator as the root of that number raised to the power of the numerator. Let's look at an example. When we have 9 raised to the power of 3 over 2, since our denominator is 2, meaning square root, so we're taking square root of 9 raised to the power of our numerator here, which is 3. So square root of 9 raised to the power of 2, raised to the power of 3. So we'll be having the square root of 9 raised to the power of 3. I can write square root as this, or I can also decide to remove the 2 and just write it as square root. But this also means square root. So square root of 9 raised to the power of 3. So what is square root of 9? Square root of 9 is 3. So we'll be having 3 raised to the power of 3. And when we have 3 raised to the power of 3, 3 raised to the power of 3 means 3 times 3 times 3. You can count it here: 3 1, 3 2, 3 3. 3 raised to the power of 3. And 3 times 3 times 3 will give us what? 27. So we are having 27. So 9 to the power of 3 over 2 is equal to 27. Now this is for the fractional index law. The last law we'll be looking at is the product power law. So you can see we have 7 laws of indices. The last law is the product power law. So for the product power law, whenever we have something like this, s y z to the power of n, this means that s will raise to the power of n, y to the power of n, z to the power of n. So each of the terms we pick the power n. So let's take for example, assuming we have 2 times 3 times 4 to the power of 2. Now what you just have to do when we have 2 times 3 times 4 to the power of 2, 2 to the power of 2, 3 to the power of 2, and 4 to the power of 2. Now 2 to the power of 2 is what? 4. 3 to the power of 2 is 9. 4 to the power of 2 is 16. So we'll be having 4 times 9 times 16. And 4 times 9 times 16 will give us what? 576. So these are all the laws of indices. You can see from the multiplication law, we say if the bases are the same, you add powers. You have the division law, if the bases are the same, what? You subtract the power. You have the power law, where you have a number raised to a power, including the bracket raised to another power. You just have to multiply the two powers. You have the zero index law, any number raised to the power of 0 equals 1 as far as that number is not equal to 0. Then we have the negative index law, where any number raised to a negative number, we will take 1 over that number and the power. So we have a to the power of negative n, we will take 1 over a to the power of n. You have the fractional index law, where we have any number raised to a fraction, you just do the denominator as the root of that number raised to the power of the numerator. And we have the product law, product power law, where we have numbers in the bracket raised to the power of n or raised to any power. You just singular the numbers and raise them to those powers individually and you solve. So these are the laws of indices. If you enjoyed this video, ensure you subscribe and like. In our next video, we will be looking at how we can apply these laws in solving questions. We'll be solving questions applying all these laws. So watch out for our next video. If you've not subscribed, subscribe, because our next video will be applying these laws to solve questions under indices.